Was it, it looks like the line was really long to register. Is that the case? Oh, man. I'll bet we're going to have people trickling in for the next half hour. Anyway, welcome to TechEd. I'm Don Box. We're going to spend 3 hours together talking about what happened. You know, what is this .NET thing? Why did it happen? Where did all the stuff I used to know move? And, you know, what are some approaches I can use to live on this platform? You may notice from the title slide here that I work at a company called Microsoft. I sold my company in November of last year, and they had this resort up in Redmond where there's lots of activities to do, and the managers all wear whistles and stuff, so I decided to go retire up to there. So I have a nice restful job, which is working on this web service GUI, which we'll actually talk about some towards the end of this talk. But what I want to do is start by just talking about, you know, what happened? Why did this .NET thing happen? There's a few interesting things to know that really give people perspective. One is .NET is really two things. For in-memory work, right? .NET, like COM before it, is really about software integration. It's about taking code written by two different people, smushing them together and getting them to work. That's what COM was about. That's what .NET is about. It is not coincidental, given the fact that pretty much every interesting .NET technology came out of the COM team back in 1997 and 1998. And in many ways, this is the next generation of COM, if you look at it the right way. So with .NET, it's about integrating software, and there are two fundamental pillars that we use in .NET. One of these pillars is called the Common Language Runtime. And the Common Language Runtime is an in-memory technology for taking code within a single process and getting it to work together. So a good way to think of the Common Language Runtime is as a replacement for ole32.dll. Right? Those of you who did COM work in the past knew that ole32 was where life began. Right? That's where co-initialize was. That's where co-create instance was. And pretty much that was where you went to get services for making code load in memory. Now, the Common Language Runtime is only one part of the .NET story. The second part is this thing called XML Web Services. And the idea behind XML Web Services is it's the way we integrate software across machine boundaries. So the CLR is within a single machine, within a single process. XML Web Services is for cross-process, but most interestingly, cross-host integration. That stated, the similarities between the two technologies are staggering. And they are much more similar than they are different. However, what we're going to do in today's session is spend most of the time, but not all of the time, talking about the Common Language Runtime simply because it touches everyone right away. If you are going to start drinking from this trough, which we call .NET, it is inevitable that you're going to be doing stuff with the Common Language Runtime immediately. How quickly you move to start using XML Web Service technology will vary depending on the domain you work in. Some people will actually do that stuff first, and that's probably the reason they're moving. Other people don't have a need for some of these things and may not be applying these ideas for months or years to come. And so for that reason, I'm going to skew today's discussion to be maybe 70% about the Common Language Runtime, which is in memory, and about 30% tops about XML Web Services. Now, both of these two technologies were born in late 1997 and early 1998. In that period of time, it was a very interesting time at Microsoft. The MTS team, Microsoft Transaction Server team, had just been merged with COM. And so there was one unified team that was there to build all component services. And there were basically issues going forward with COM. right? And the issues had to do with the line between component boundaries, right? All of these integration technologies, be it COM, Common Language Runtime, XML Web Services, all have a common theme, and that theme is this. Oh. Hold on, I know how to do this. I would like to, oh, hold on. There's another presentation tool on this machine. There. That's the picture I wanted to draw. All of these technologies focus on that line. The line that separates two independently developed pieces of software. And a lot of COM, in fact, pretty much all of COM was focused on that line. And what happened was we had hit the wall in terms of what we could do with the technology we were using at the time. There were two fundamental problems with COM that needed to be addressed, right? And I'm sure you've seen talks about how .NET replaces COM and COM was all evil and bad and this is all going to be great and wonderful. But there were two fundamental problems that there was no engineering way out of. Problem number one had to do with something we call metadata. So in any kind of component system, we typically have some sort of metadata that tells us about the code, right? If you look at component technologies over the years, everything since the 1980s forward, there's some form of metadata that allows me to walk up to a component and say, I wonder what I could do to this thing. Now, in the old days, that is, hold on, let me get a new shell. Let me go to the old component repository. So I'm going to basically do a UDDI lookup on my components and see all of the components that are on my machine. So here I've got a list of all of the old school pre-COM components, and notice I've got a lot of them on my machine. Now fortunately they have metadata, so I can walk up to any of them and run the tool dump bin on, say, user32.dll. And I can see what's inside of the DLL. That is, I can discover what the programmer was thinking I should see when I saw his code. It gives me some insight as to what the programmer wanted me to be able to do with his code. And the way we do this on Windows is already a quantum leap forward from the old original Unix model, where basically all symbols were exported all the time. In Windows, we only export a subset of the symbols we actually want you to have public access to. Now, the problem with this format was I couldn't see the relationships between the operations. I couldn't understand anywhere close to what the semantics were of this component. And so what COM did was it added type information to the metadata. And so if I walk up to a COM component, what happens if I run dump bin? Well, let me try that. Instead of running it on user32, I'll run it on msxml3.dll. And notice that dump bin, this is the old school pre-COM metadata tool, isn't all that interesting when I'm walking up to a COM component. Why? Because COM introduced a new metadata format that better conveyed programmer intention. When we go back to the line between your code and my code, I want to understand what you mean. In an ideal world, we would have 100% pure semantic contracts. That is, if I write a piece of code that cuts grass, all I would do is write in English, here's some code, if you give me $5, I'll mow your grass. Right? And the computers would just sort it out. I mean, that would be the ideal. We're nowhere near close to that. Right? Not even close. But COM got us closer. Right? Because COM allowed us to see the type hierarchies and allow us to understand the relationships between how the pieces of code interrelated and could be used. So the metadata viewer for COM was called OLEView, and if I run that on MSXML3, notice that I'm looking at a different metadata form which shows me hierarchy and how types relate through inheritance and through parameters. And I have a much better, clearer picture of what's going on in the component. This was goodness, right? This was a necessary but insufficient step towards this semantic nirvana, right? Now, here's the problem. The problem is MTS believed in this story. The MTS team said, boy, if the programmer could be more expressive about what his code means, then he will have to write less code because all he has to do is write about his code. Right? Metadata is data about code for the purposes of today's discussion. And so the idea behind MTS was, let's make the metadata format richer. Let's add additional pieces to the metadata format that allow the programmer to say, you know, this piece of code needs concurrency management done for it. Right? So rather than writing a bunch of code where we're writing a bunch of locking code and dealing with critical sections and trying to avoid deadlock and all of that nonsense, rather, I simply declare my intention that says, I wish this code was protected from concurrency. And that was done by adding attributes to the metadata. That was the fundamental principle of MTS. Well, here's the problem. Most of that metadata belongs inside the DLL. Because as you are writing the code, you the developer, right, who better understands what the expectations of that code are, what the requirements of that code are. And so the idea behind MTS was to allow you to declare your intention in metadata. And if you worked in C++, you had it made. Because C++ programmers who use COM had this thing called IDL. And IDL had a backdoor through which you could drop new attributes in, which would funnel into the type library. And MTS could then look at that at runtime and say, aha, before I load this piece of code, I'm going to make sure I can respect the wishes of the programmer. Right? So if he said he needs a transaction, I will make sure he can have a transaction. Now, if you work in C++, you could do that. How many people, show of hands, work in C++? Look around. All of the C++ programmers on the planet are actually in this room right now. Statistically, you do not exist. Especially in the mid-1990s, when the MTS team was focused on people using databases, building enterprise systems, who were primarily, at least on the Microsoft platform, using Visual Basic. And so, while the C++ programmer could put arbitrary gunk into his metadata for MTS to then come pick up, what about VB programmers? How many people work in VB? Be proud. This is your year. Come out of the closet. Right? We're having a VB Pride parade later on today. VB programmers were screwed because they couldn't see the metadata. The metadata was just this gooey, grungy detail that the VB tool took care of for you. Right? The idea was, there, nice VB programmer. You go to the gym, you come back at 2 o'clock, and we'll have it ready for you. Right? And very much a hands-off attitude. And so MTS couldn't expose their primary programming model to their primary customer. Do you see the problem here? They had this beautiful model of declarative, intentional programming, and their primary audience couldn't get to it. So the MTS team went to the VB team and said, please, 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 let us do this, make this possible so we can innovate. And the VB team said, I'm sorry, we have to go build web classes or whatever they were building that year, right? So the bottom line is the VB programmer couldn't augment the metadata. So this was a problem. Not having extensible metadata is bad Because inevitably, if metadata is that useful, then everybody should be able to do it, right? And the problem with COM was the metadata format, for all intents and purposes, was not extensible. You got what middle expected, right? If middle could deal with it, great. The extensibility model was not reliable, it was buggy, and only available to C++ developers, which meant it was largely useless. Now, that was problem number one. Problem number two comes back to this picture. Remember I told you that the ideal, right? The ideal would be to have 100% pure semantic contract. That is, I tell you, I'll mow your lawn if you give me $5. And that would be it, right? And the software, some virtual machine would just sort it all out. I mean, that would be the dream, right? Because then we could go on and solve more interesting problems. Unfortunately, we're not there yet. But in COM, we were actually pretty far from that ideal, right? As much as it was nice having types integrated into the loader and such, if you looked at a COM contract definition for mowing your grass, it read like this. I will give you a 4-byte cookie. That 4-byte cookie is the address of an array of function pointers. If you go to the 0th entry in that array, invoke it after passing a pointer to a 16-byte structure on the stack and a pointer to a pointer, I will come back to you with a second cookie, or I will give you back an error. And if you look in EAX, you will see either 0 or 800400005, which will tell you whether or not I could give you the second cookie. Oh, and by the way, I'm going to give you the second cookie, and you had better remember to go through the third entry in the V table later on to make sure that I know you're done with that cookie. Oh, and now you'd like to call the method. Great. Well, in order to be able to cut your grass, we're going to have to share a data structure which represents the lawn. And because I may have to reallocate buffers, at offset 8 into that data structure, I need you to go off and allocate 24 bytes of memory using cotask.mem_alloc, so that when I get that thing, I can go back and do a cotask.mem realloc and grow it or shrink it to give you back the new image of your lawn. Okay? Oh, and by the way, the strings, for this part of the string, I need this string to come in allocated from this heap over here, which you get to through sysalloc string. But for the other string, I'd actually like you to do a cotask.mem_alloc, because I'm going to do something different with that, right? How much semantic intention is in that line? The description I just gave you has nothing to do with semantics. It has nothing to do with meaning. None of what I just told you had application import. It was just detail. That detail was what was a byproduct of this thing that COM had called a binary contract. In COM, we make a big deal about binary contracts. That is, I know the in-memory representation of everything it takes to cross from my code into yours. And that's what COM was all about. And the good news about this was it was fast. It was as fast as humanly possible. You cannot make it any faster, I promise you. The problem is, just making it fast isn't enough. Cars could be made much faster without all of these options like doors and seats, right, that weigh the car down. Right? If you were willing to drive in a more uncomfortable position, right, the car could go faster because we could reduce the weight. But would you want to drive a car with no doors and no seats? In all likelihood, no. So the sacrifices we made to have binary contracts were performance related, but the problem with them was, A, they complicated everything. Every aspect of COM plumbing was incredibly hard to build. Right? And anyone who's ever done stuff like universal delegators or any kind of interceptors based on COM knows that it is a very painstaking, detail-oriented task. The second problem, which influences everybody or affects everyone, is this notion of binary compatibility. That is, if I make a change that has no semantic weight, I still have to redeploy the world because COM cared about a lot of stuff that I didn't care about. And so what we want to do is have a component technology that only cares about what we care about and sorts the rest out. So, Back in late 1997, the COM team realized, well, geez, the metadata format is not extensible. VB doesn't seem all that willing to move. And we've got this binary problem. Why don't we write a new version of COM that supports the same programming model based on strong typing of contracts, but has the features we need? And so the Microsoft team went off and built something called COM3. COM3 was the original name for the Common Language Runtime. And COM3 was called COM3 because Olay went from Olay 1 to Olay 2. And since we didn't care about Olay anymore, it seemed natural that it should be called COM3 as opposed to Olay 3. Now, COM3 lasted for a very short period of time as a name. Because as it turns out, under certain Microsoft operating systems, if you create a directory called COM3, you can never delete it because the file system thinks you're trying to delete the serial port, because COM3 is a reserved name for the serial port. This is a true story. So it was quickly renamed to the Component Object Runtime. It was first revealed to the public in 1998 at the San Diego PDC. Mary Kirtland wrote articles about it in 1998, and it finally shipped in February of 2002 after being renamed to the Common Language Runtime. And so the CLR has its roots in COM, and it was designed to address these two fundamental limitations of COM. Limitation number one was the metadata format was not extensible. Limitation number two was there was too much in-memory, useless, non-semantic detail in that line that you're looking at right now. So, the CLR replaces COM. It is a new implementation. You can think of it as a brand new, ground-up implementation of Olay 32. If you really want to put this into COM terms, this is the replacement for Olay 32. Bringing the CLR into memory does not require COM. It's an important observation. You can use the CLR without having any calls to co-initialize or co-initialize EX. We do not require COM to work. The shared source common language infrastructure, formerly known as Rotor, is our implementation of the CLR that runs on top of FreeBSD Unix. And there's no COM on FreeBSD Unix. Right? We didn't need to go off and build Olay 32 and all of that stuff to get this to work. Right? That stated, as we'll see later on today, there is a coexistence strategy to allow code that was written against COM to peacefully coexist with code written against the CLR. But please be aware they are different technologies. But the CLR is the heir apparent. It is the historical successor to COM. Okay? So, let's talk about these two problems. Problem number one was the lack of extensible metadata. Let's do that one second. Let's start by talking about the moving away from binary contracts. So what I'm going to do is write a simple component for you using my tool of choice. So let's go to this shell. What I'm going to do is write a simple component to cut our grass. And for this example, I'm going to use C#. I'm going to use C# because it's the simplest language to use that allows me to put semicolons at the end of the line. Later on, I will talk about how to do this stuff from C++. And be aware, you do not need to get off of C++. If you love C++, stay in love with it. Right? You don't have to leave your wife just to come to this platform. So, let me write a simple type. Like the world of COM, in fact, let me make the font bigger, since I saw some people over 20 in the room. Okay, that should be better. Public class grass. Public bool B1. Public double N. Public bool B2. Public string S. And I'm going to have one method, public void display. And in here, what I will do is system.console.writeLine B1. N, B2, and S. Look good? So I've written a simple type definition in a programming language that I picked at random. And what I'm going to do is build a new CLR component. So to do this, I crank up a shell, and I'm going to run the C# compiler and say /t library, which means build a DLL as opposed to an exe, and then give it grass.cs. And notice that we've got a DLL that was produced by the C# compiler. Important observation. To work on this platform, you need a new compiler. Because we have a new metadata format, we have a new executable file format, and so you need a new compiler and linker to be able to program on this platform. Fortunately, we ship compilers for every language we support, and they're bundled for free with the Framework SDK. So you don't have to buy anything to go work on this platform. And there's a perfectly good IDE floating out there called Emacs that you could use for development. Right? If you want to buy Visual Studio, hey, go in peace. Please do. Right? It helps pay my salary. But you don't have to buy anything to do this stuff. But you do need a new compiler. Right? Because we have a new format. And that was kind of how we got the extensibility in. So, what I'm going to do is now write an application against this guy. So class app, static void main, grass, G equals new grass, G.B1 equals true. I'll just fill up the fields real quick. Equals 2345.6.8, whatever. G.B2 equals false. G.S equals hello, it's me. And then finally G.display. Let's compile this thing. Notice the program does not compile. The program doesn't compile because I am using a type in another component. Right? My application, app.cs, assumed the presence of that second component, grass.dll. So to get this to compile, we do that. /r says reference the metadata in that component over there so that the types that he exports can be used in my program. If you're a VB person, this is like doing in VB6 project add reference. And if you're a C++ programmer, it's kind of like doing both a sharp include as well as a pragma comment lib, right, to do the linker. Right? Because in C# we have a single compiler that does compilation and linkage in one pass. So we not only have to see the lexical definition of the type, we also need to make sure we have the linkage when we build the thing. Okay? So, let me run the thing just to show you that this .NET stuff is not all vapor. Wow. What? I'll run it again. Watch. Notice it runs the same every single time. Do we have that with COM? Of course we did. Now, big deal. So I wrote a DLL and I wrote an application. How is this any better than COM? Well, let's walk through some scenarios. Let me go into grass.cs. Let's assume that your organization hires a new developer. We will call this developer Junior Engineer Jimmy. And Junior Engineer Jimmy is not the most experienced developer, but he wants to feel like he's contributing right away. So what he does is he walks up to all the source code and he says, well, you know, this would be a whole lot easier to maintain if all of the fields were in alphabetical order. Make sense? So Junior Engineer Jimmy comes along, reorders the declaration of the fields, and then, of course, goes off and rebuilds the DLL. Now, What would happen in COM if I had a C++ COM component and in the IDL I reordered the field declarations in a structure or reordered the method order of declaration of methods in an interface, which is the same problem? What would have happened? Would it have worked? No, right? We'd get we'd get a house call from the doctor, and you know which doctor you'd get a house call from, right? Dr. Watson. So, let's see what happens in this .NET world. Notice the program still works. Why? Because in the CLR, we do not believe in binary contracts. We do not know physical representation of diddly squat when we are building the code. That is, there are no data representation dependencies in this piece of code that relies on that piece of code. So there is no binary contract. Now, that's interesting. That's weird. That's really weird. So how on earth does this work? Well, what we would like, the code we want, right? Let's talk about what would have happened in COM. So what I want to do is deconstruct these or disassemble these four statements which I've just selected and show you what the x86 ASM would be, because it's actually pretty interesting. So main.asm. So the first thing that would happen is we'd move into EAX the local variable, probably off of the stack frame. So that's basically storing the reference or the pointer into the EAX register. And then from there on out, the four field accessors would look like this. This is pseudo assembler, right? But that's basically the sequence of machine instructions that the original code that I wrote would be translated to at compile time in the world of COM. So in COM, if I had written a piece of code, that would be buried in the client executable, which means what? Those offsets that you see in the instruction stream, we can't change them. Which means you better not reorder that thing because it'll break. Well, let's look at the actual assembler that was produced by the original compiler. So I'm going to open up a tool called ILDASM, and I'll run it on app.exe. And let's look at the code for main. So there selected is the code that the compiler generated. This was generated at development time. Please notice that this generated code has 0 physical offsets in it. Rather, it has references to metadata tokens that says, look, take the value 1 and put it in the field called B1 whose type is Boolean. I don't care whether it's the first field or the last field or whatever, but he's got to have a field called B1 and it's got to be of type Boolean. And I don't even know how big a Boolean is. Some machines may store Booleans as a bit in a bit mask. Some machines may store it as a 128-byte GUID. Who cares? All I know is that it's going to be true or false, and then it's going to be stored there. Same thing for the N field, same thing for the B2 field, so on and so forth. So all of the in-memory representations have been virtualized away in this instruction set. This is not x86 machine code, rather it's something called intermediate language, sometimes called MSIL or CIL for Common IL. Now, Look at that code. Play engineer for a second. How would you make that code run on a machine? Kind of the obvious way to do it would be to say, well, look, I'll walk through statement by statement and interpret what that statement means, because it's a fixed instruction set. I could probably build that table. It probably wouldn't be that hard. And so building an interpreter around this is actually probably doable. However, that is not what we do, right? The reason we don't do that is that would be slow. And this technology has to be used, right? It is very, very telling. When a vendor builds a technology for themselves to use, that's really, really interesting, and you should pay attention, right? Not every technology vendors build is meant for them to use themselves. So, for example, Sun did not build Java to rewrite Solaris in, right? They wrote it to put applets on a web page, and for that it's a perfectly reasonable solution. Microsoft did not build Visual Basic for use internally, right? I don't know how to break this to you, but we do not build VB in VB, right? It's actually built in C++. VB is for you guys to use. We don't use it internally, right? It's just a product. In contrast, the Common Language Runtime was built for us to use. And so it's got to go really fast, because if our stuff is slow, we're screwed. And so we never, ever, ever interpret the IL. Rather, we always run this. And in fact, if I were to bring up a disassembler to monitor my running program, that is precisely the code that would execute when main is invoked. However, that code is never part of the component. That code we're looking at here never travels from point A to point B. Rather, it is calculated on the deployment machine. Because if we bake that in at development time, then what happens? We have a binary contract, and we have very, very tight coupling, which is badness. So instead, what we do is we defer generating the final x86 machine code until we're on the deployment machine with the components we will be running against. Because I may have built against a component and someone may have recompiled it without changing the version number. I'll never know that. That shouldn't break me, right? Certainly for innocuous changes like I just made. So what happens is we calculate this on the fly on the deployment machine. Now let's talk about how that happens. I'm going to use another presentation tool. So when a type is initialized, there's a data structure for the type that gets allocated. This data structure is referenced by every instance of the type, right? So it's kind of like a C++ V table, but not really. Because it actually has about 40 bytes worth of goo that's got nothing to do with V tables. But at the end of this data structure is something we call the method table. And there is an entry in the method table for every method on the type. Every method of the type will have an entry in the V table. Whether or not it's virtual, doesn't matter. If it's a static or an instance, doesn't matter. If it's a constructor, doesn't matter. It's got an entry in that table. You with me? All calls go through the method table. And the method table, each entry in the method table is actually a function pointer. And that function pointer points to a data structure that looks like this. The first n bytes, I think it's 6 bytes, the first, let's say, 6 bytes of that data structure is actually an x86 call instruction. So that when I call through that function pointer, I'm just calling another call statement, and that call statement is always wired to the same place. It's wired to a piece of code inside the CLR. And remember, all of this stuff is generated when we load the type. Right? So that data structure I'm drawing here on the far left, that's allocated when we initialize the type on the deployment machine. So the method table is allocated as part of type initialization. Each method table entry points to something we call the stub, not in the COM sense. And that stub has a call instruction to a block of code known as the JIT compiler, or just-in-time compiler. So the first time I make a method call, I'm actually calling into the CLR to invoke the JIT compiler. Now, the second piece of this data structure is a pointer to the in-memory image of the IL. So when we memory map your DLL into memory, the method stub will point to the exact IL for that particular method. So when a type gets loaded, all of the method stubs start off with the exact same instruction here, but they'll have different pointers down below. Because that's how we're able to go back and find what method it is we're actually trying to JIT. When the JIT compiler gets invoked, it goes off and allocates a block of memory, translates the IL into x86 machine code, and then most importantly, overwrites the stub to now have a JMP instruction to jump to the actual method body. See how that works? So the first time we make a method call, we actually take a perf hit to allocate memory and do the back end of the compiler on the user's machine. And that's how we get the binary contract. That's how we get the perf, so that in the steady state, there is no real perf penalty. Right? If you look at the generated code, it is indistinguishable from VC6 optimized code. Right? There's not a lot of weird, interception goo happening. Pretty much, if I'm making a method call that calls another method, the generated code looks, functionally equivalent and performance equivalent to what we had before. Now, this is goodness, and one of the nice things about this is the method bodies that we're actually going to execute tend to get allocated in order of their call sequence, which has very good cache locality of reference characteristics. That is, it has the tendency to reduce the overall working set because the code I'm actually using tends to be on the same virtual memory page, which means I'm doing less work with the virtual memory manager, which is always expensive. Now, the problem, the downside of this approach is, guess what? When we initialize the process, there's going to be a lot of JIT overhead. And for a server-side process, where what we care about is throughput, it's an acceptable trade-off. Taking a little bit of extra latency to get the process up and running is more than offset by the savings we get by having a smaller working set. However, what about those pesky users? Right? If it's a user interface app, right, where we expect the user to double-click it, and if he sees that hourglass, he's going to hate it. We need the ability to, in essence, offload this work to install time. And so there's a tool that ships with the framework. It's actually on the, it's a part of the redist as well, called ngen.exe. And ngen.exe generates native images that contain x86 machine code. And it's meant to be run at install time on the deployment machine. And .NET aware setup infrastructure knows how to run ngen and make sure this happens for you. So it's not a horrible burden if you've got a setup program. And if you've got a script, this thing is always in the path, so go for it. So ngen.exe takes the name of the component, so I'll say grass.dll. It goes off, generates the native image, and puts it into a machine-wide cache. That machine-wide cache will be looked at by the CLR when I need to load the code. And if I've got something in the ngen cache, we will use it. If there's nothing in the ngen cache, then we'll use the basic IL. Let me go ahead and NGen the app as well. So now I've got cached native images of both of these guys. Let me run the app now. There. Wasn't that faster? No. I mean, you can't really detect it for this simple example. But the idea is all of the code was x86. However, the x86 code was not calculated until I got on the deployment machine. Why is this important? This is important for two reasons. Reason number one is NGen calculates the binary contract, right? It starts putting in hard offsets into data structures because we're on the box and we have all the components we're going to be running against. Right? So by running it on the deployment machine, we're guaranteed that the components we are running against are the same one we compiled against, did the back-end compilation. Right? So it gives us the perf of binary contracts without the brittleness. The other reason it's important is, as you know, by Christmas time next year, most people will have Itanium boxes, which don't run x86 very well. And so obviously, I would like to use the JIT compiler and the native image generator on the Itanium box, even though I'm still working on, a 286, right, or whatever it is they give me. Right? So it does give you processor independence. But processor independence is a bit of a red herring when 90% of the computers on the planet all do x86. The real motivation is to reduce the coupling between components. Now, let's talk about one more thing. What I'd like to do is go back and undo this change. Or let me just make it even more wild. There. Now it's really wild. What I'm going to do is recompile just the DLL. So now I have changed the offsets, if you will. And I'm not going to regenerate the native image. And even if I did, it wouldn't matter. What happens when I run app? The native image was built against one particular compilation. I have now recompiled. So what's going to happen to that native image? It's stale. Because the things it depended upon are no longer reliable. So let me go ahead and run this thing. And it still works. It works, but it did not use the native image that was cached. Because when the native image was produced, it recorded, in essence, the timestamp of every DLL it was built against. And if at least one of them changes, then we no longer use the native image and it's useless. And I would have to rerun NGen. So I get the flexibility of this kind of more loosely coupled world, but in the normal scenario where that's not happening, I actually get the perf of binary contracts. Okay? So, problem number one with COM was that it was very, very detail-oriented, and we no longer have that. And in fact, we no longer know the data representation of anything. And in fact, guess what? The common language runtime does not care what order the fields are declared in. It will actually reorder the fields to get optimum padding and layout. So in the old versions of the specs, they used to talk about this virtual object system, right? We don't really know what the object's going to look like. All we know is that it's going to have 4 fields, and there'll be a double, a bool, and a string. How many bytes that occupies or what the offsets will be, that is postponed until we're on the deployment box. And so what order you declare them in has 0 impact on the world. Okay? Cool. All right. So we've seen how virtualization solved the binary contract problem. Let's talk about the more fundamental problem, which was that the metadata was not extensible. So, you may notice that we're actually doing a cooking competition here at TechEd. We're baking developers, which is why it's so warm in here. It'll get up to 350 degrees by the end of the talk, at which point we'll put a fork in it and pull you out of the oven. What I'd like to do before we go on is take a deep cleansing breath. Inhale. Exhale. Keeping you awake is going to be my hardest job today. So, let's talk about the metadata problem. What I'd like to do is write a new program. Public class, attendee, public string name, public double age, public bool asleep. Okay. Class app. Static void main. What I'd like to do is write a program that uses metadata to kind of motivate why metadata is important and why metadata in the CLR is fundamentally different than the way it worked in COM or even the way it works in Java. So, a very easy way to get into this metadata-oriented programming is to say, well, look, what I'd like to do is have a SQL statement that creates a database schema that matches my class. Maybe I want to build some object relational mapping layer. Right? I'm not advocating you do that, but if you wanted to do that kind of thing, then you probably want a table whose schema had some relationship to the format of the class or the structure of the class. So what I'm going to do is write a program that generates that SQL dynamically. Cool. Let me recompile that. Let me compile this. CSC SQL.cs using system. And when I run that, notice that a new SQL statement was generated dynamically, which I know is very amazing. Right? The fact that we have printf is really great. What I'd like to do, though, is make this program use the metadata. I just kind of hard-coded the strings. And of course, what the problem will be is if I modified the schema of my type. So for example, if I change this to first name and last name, and I make age an int, recompile it, notice that the database schema didn't keep up with the way my class was structured, right? So what we want to do is use metadata to solve this problem. It's kind of an everyday programming problem that many of you face in one form or another. So what I'm going to do is use the metadata. Now, we had metadata in COM. I could call, in the old days, load typelib or load reg typelib, then do a get type info to look up the type by name, and then enumerate all of the member defs. How many people programmed against type infos and type libraries? Yes. Was it fun? No. But it was impressive to your friends, right? There's no question that if you were like on the singles market and looking to date, you know, that would really impress people of the desired sex. I know that from experience. But in general, it was kind of a useless skill except for, you know, getting what you needed. So what I'm going to do is modify this program to do the moral equivalent. So the first thing I'm going to do is get a type description. This is the moral equivalent in COM to iType info. Right? I was going to try and bring this back to COM. In COM, we had this thing called iType info. And the way I'm going to get one is by saying type of, or how about this? Type.getType argv sub 0. So what I'll do is I'll actually take the name of the type that you want to generate the table for as a command line argument. And so what I'll do is I'll call type.getType to load the metadata for the desired type. Then what I will do is modify this thing. So the first thing I'm going to do is print out the type name like so. Type.name cool. So let me recompile this. I'll run SQL on attendee. Create table attendee. I'll run it on system.object. Create table object. You get the point, right? System.collections.stack. Great. It's able to load that type. Looks good? Now what I want to do is walk up and find all of the field declarations and have a column in the database that goes along with that field. So to do this, what I will do is say for each field info field in type.getFields. Do something. Okay? So first thing I'll do is I'll just print out the name. With a space. And I need system.reflection. Great. And now if I run that on attendee, notice that I'm getting the list of fields. Right? This is a step forward. What I'd like to do now is A, insert the commas, because it's not legal without the commas. And let's get a type affiliation. So the hardest part of this program is getting the comma right. And getting the type name won't be so hard, because I can just say, go up to the field and get the field type, which is itself a type, right? And I can actually say field type dot full name. Cool. Let's compile this. And hey, we're cooking with gas. Notice that if I make changes to the class definition, all I have to do is rerun this program and I get the SQL statement that goes along with it. And in fact, I could just bake this into my plumbing so it was part of the type. Just to prove that it works, let me go make another change. We'll go back to a single name field, and I'll make this of type double. Recompile. And notice now that the schema of the table matches the schema in the class. Life is great. Is this legal SQL? Sure it is. Microsoft, we're announcing at TechEd this year, we have bought ISO, and we're redefining ISO ANSI SQL in terms of CLR types. So by the end of the week, that work should be done. I'm kidding, of course. I have to be careful now that I work at Microsoft. People may think I'm serious about that stuff. Obviously, this is not real SQL. So let's write a little mapping function that does the trick. So I'll write a little function called getSQLType. It'll take the field declaration, and basically what I'll do is switch on field.fieldType.fullName. And if it is system.int32, then I'll return int. If it's system.boolean, then I'll return bit. If it's system.int16, I'll return small int. I think that's right. And if it's string, And if it's anything else, we'll just return, the mystery field. Cool. Let me go plug this guy in. Recompile it. What's age? Looks like I missed one. Oh, age is a double. Don't quote me on this. I think it's real. There we go. If not, I'll go fix the code. Make sense? So, having metadata be ubiquitous and high fidelity, hey, that's goodness. This was kind of there in COM, but programming against I-type info, as we could see earlier on, was not the most fun thing to do. Right? You had to be really desperate to write, type lib code. Right? That had to be the only way to get what you wanted. Because it was not something you would do idly for fun, right? This, on the other hand, I could have written in VB. I could have written after a few cocktails at lunch, right? You could see it didn't require a ton of attention to write this code. Now, let's talk. So I haven't added any new real functionality to what we had in COM, but let's talk about one of the problems with this. Let's add another field. Public string. Reason for sleeping. Let's recompile. So notice that the reason for sleeping field or column uses the same SQL type as the original name column did. Does this make sense? What do we know about the name? It's probably going to be a fairly short string. Agreed? And I'm probably going to need it. And I probably might even want to make it a primary key. Who knows? On the other hand, what do we know about reason for being asleep? Well, there are many reasons you're asleep. The speaker is boring. The room is too hot. You've got a hangover from the night before. Lunch was too filling. You could go on and on and on about why you would fall asleep at a session. So, will 32 characters be enough? No. So the problem is, I cannot tell from the static fixed metadata what your programming intention was. That is, I can't tell the difference based on the way the thing sits now, what the difference in intention is between name and reason for asleep. They look the same. They're both strings. What we'd like to be able to do is get a pipeline into the programmer's head so we know what he meant and what his desires were. What we'd like to be able to let him do is add the moral equivalent of footnotes like this. I want this string to be really long. I want this string to be fairly short and indexable. Make sense? That would be the ideal. To basically be able to walk up to anything in my program and write footnotes about what I really meant. Kind of asides that you might be interested in if you really wanted to know what I was thinking about. Now, in COM, we couldn't really do this because the metadata wasn't extensible. In Java, you couldn't really do this, and in fact, it cost us $20 million when we tried to do it with JDirect. Right? Fortunately, right, there's no overly restrictive, hideous, heinous licensing agreement on this thing, right? So we can do whatever we want. So what we did was we made the metadata extensible, and we made extensibility a first-class construct and baked it deep into the way the type system works. So what I would like to be able to do is say the SQL type for this guy will be varchar 64, let's say. And the SQL type for this guy will be text. Make sense? And fortunately, because the metadata format is extensible, and because all languages that support this platform have to make that extensibility visible to the programmer, the feature that the MTS team needed so desperately for transactions now is available to everybody. So, let's try and compile this. Notice it doesn't compile because because the attribute SQL type does not actually exist. It is something I just made up for this talk. Make sense? Because extensibility is a first-class concept. Anybody can do it, right? But along those lines, that means that you have to do it. You have to take a step to do it. And because we believe in strong typing, we don't allow you to just stick any old thing in there. Rather, we expect you to have a public type whose name matches the attribute. So now I've declared a class whose name matches the attribute. Now we're closer to compilation. Let's try and compile. So it recognized that we have a class with the correct name, but it said, but wait a second. That class wasn't designed to be used as an attribute. It's just a plain old user class. So I not only have to have a class with this name, I have to, again, make my intention explicit by implementing the marker type system.attribute. And now, we are so close to compilation. The problem is I wanted that attribute to take a parameter of type string. We believe in strong typing. We need to have the ability to inform the compiler what legal signatures are available. So I need to be able to say, by the way, to use this attribute, you can provide a string, or you can provide an int, or you can provide a Boolean in a string, or whatever it might be. So the way I do that is I simply write a public constructor whose signature matches what I want. It does not have to have a body. It just has to be there as a prototype. And now, the program compiles. And my metadata attributes are stored with the rest of the metadata, and I can get to them through reflection the way I got to anything else that was in the metadata. Great. So now, why don't we go ahead and run the program. Notice the output of the program didn't change. Because metadata attributes are passive. By default, they are passive. They just live out in the DLL, and except for making your DLL a skosh bigger, there's no performance penalty for having them. They're cheap. Have fun with them. Right? To make them do something, typically reflection-based plumbing needs to go out and look at it and react to the presence or absence of the attribute. So what I'm going to do is go back to my method, get SQL type, and I'm going to check for the existence of that attribute. So I'm going to say if field.isDefined type of SQL type. Then I'm going to return custom. So what isDefined does is it walks up to the metadata node. It's like a DOM. It walks up to the node, be it a field, a type, a method, a parameter, whatever it is. And it says, do you have a metadata attribute of that type? If you do, return yes. If not, return false. So let me go ahead and run this thing. So notice now my logic in my reflection infrastructure picked up on the presence of that attribute and did something special, but it didn't do what we wanted. What did we want it to do? We wanted it to reach in and get that parameter out of the attribute and use that. So to do that, I have to be a little bit more fancy. I actually need the object. So I do field.getCustom attributes type of SQL type true sub-0 as SQL type. So now I've got the attribute object, but the attribute object has no fields or methods that are interesting. So what I'm going to do is add a public read-only field called type name and say this dot type name equals s. So now I will return @.typename, and we should be in good shape. See how that works? So now my program was able to pick up this metadata attribute and act on it. And I can apply it anywhere. So for example, I can say that I want this field to be of SQL type bit. Right? Because either you have age or you don't. Right? That's all that really matters. So let's compile it. And notice now that age is in fact of type bit. Make sense? We can add additional properties to the attribute. We can make it as rich and expressive as we want it to be, but you get the basic gist. One other thing I want to tell you about attributes is more often than not, we want to constrain where the attribute could be used. So for example, if this class had a method, what does it mean to say what the SQL type is for a method? Makes no sense, right? Because the method is not about representation, it's about operations. That doesn't get stored in the database. So what I'd like to do, unfortunately this thing will let me compile it, which is misleading, because I'm not going to recognize it unless it's on a field. So when I declare the SQL type attribute, there's a meta attribute I can apply here called attribute usage, attribute targets dot field. And now the compiler error is saying SQL type is not valid on methods, it's only valid on fields. If I comment that guy out, it compiles just fine. Make sense? So, why did COM go away? Right? Why was COM stopped as a forward-moving platform? Two reasons. The brittleness of the binary contract and the lack of extensibility in metadata. We saw that the brittleness of the binary contract was addressed through the use of IL and virtualization. Very important concept. And we saw that the extensibility was a first-class concept, and every programming language supports it innately, and it's just goodness. Cool. Now, one last thing I would like to show you, and then I would actually like to take a short break, because you look like you need a break. But I would like to show you one thing. Remember I told you if you want to do development on this platform, on the CLR, you need a new compiler. That does not mean you need a new language. You can use your existing language, provided it's C++, and it will just work. So let me demonstrate that piece of technology, and then I'll cut you guys loose. So what I'm going to do is write a new file. It may look somewhat familiar to you. I'm writing hello world in case it wasn't obvious. Make sense? What I'm going to do is compile this program using a switch called /CLR. This, in essence, replaces the back end of the C++ compiler with one that emits the new metadata format and the new instruction format, which is IL. And so I will run this on funky.cpp, and I'll run it. Voila. Make sense? But please notice that I can actually run ILDASM on funky.exe. And there's my main right there. Now, it doesn't look all that pretty, but hey, it's IL. People don't look at this, right? All of my types, Bob, Steve, all the methods are here, right? And the beauty of this feature is I can slowly, or at my own pace more accurately, start to take advantage of CLR services as I want to. And I can do this without having some big mode switch. So for example, in G, I can actually go off and say system collections stack star ps equals new system collections stack ps arrow push ps arrow push and then printf. How about this? System console write line ps arrow pop and then try catch we'll do it one more time. And of course, what will happen when we try to pop off of an empty stack? It's going to throw an exception, at which point we do that would be bad. Let's call this something else. There we go. Great. Looks good? Let me go ahead and recompile this thing. And let me bring in MS Core Lib. And there we go. Goodbye, hello. So we pop things off the stack in reverse order. The exception handler fired. I just did a toString, which is what you're seeing there. And then we do the hello world. So if I want to take my existing C++ MFC ATL COM code and bring it forward and gradually start to use these new features, right, I can do it pretty easily by just recompiling the code with the CLR switch. I don't have to abandon all my C++ code and learn some funky new language that someone else thinks I should learn. Right? If you're a C++ committed, die-hard in the wool person, hey, go down on that ship, dude. You know, you can be the last one on it, right? No one's going to force you, to get on this lifeboat, which we call C#, right? If you're convinced C++ is the way, go in peace. And the beauty is the compiler's more than happy to support that. Okay? And it does it without a performance penalty. There's no weird mode switches or anything like that. We'll come back and talk about COM interop after the break, and we'll talk about the differences in approach. So what I'd like to do is take a realistically 20-minute break, but I'm going to tell you 15 minutes. So I'm going to start up in 20 minutes. So please don't be late. So go use the restroom, whatever you need to do. Thanks, bye.
t'en fous, baby, tu t'en fous, baby, tu t'en fous. Head to my D, baby, tu t'en fous, baby, tu t'en fous, baby, tu t'en fous, yeah! Been many years now, baby, since I took you for my bride. You were such a young girl, no secrets could you hide. Everybody knew you were the favored one. Your love would shine so strong, just like the moon, just like the sun. After all these years, baby, I want you to see that you're still just an angel, still just an angel, still just an angel. Well, there's a hard wind blowing up from the Gulf of Mexico. Both the doors and the windows we've been through this. We've been through this before. We'll put the kids in bed. The fire's burning low. It's just you and me, baby. And there ain't nowhere we gotta go. And after all these years, baby, I want you to see that you're still just an angel. Still just an angel. Still just an angel. Alone on his front porch, sitting in rocking chairs. We rock just a little bit slow, but we don't seem to care. When the sun goes down, we're gonna head on out to the Fado. All our grandchildren gonna be there, and all the people that we know. After all these years, baby, I want you to see that you're still just an angel. Still just an angel. Still just an angel. $18, $19, $20 years ago, Uncle Bud beat the hell out of Cotton-Eye Joe. Uncle Bud. Some people say Uncle Bud is dead, but they're goddamn lie. He's sick in the bed. Uncle Bud. Uncle Bud. Uncle Bud. Bud got a daughter, well, her name is Joan. What I like about her, she make an old man moan, Uncle Bud. Uncle Bud got cotton, never been picked. Uncle Bud got corn, never been shucked. Uncle Bud got a daughter, never been Uncle Bud. Oh, yeah. Uncle Bud. Uncle Bud, Uncle Bud, boots on the ground. You the biggest thing running right around town. A little bit of heaven right here on earth. Tell me what is it worth? Tell me what is it worth? Did you run a more? How you like that great big Cadillac? Did you run a more? How you like that great big Cadillac? And took all of the land. It ain't coming back, no. Left you with nothing but a beat up old Cadillac. Long black highway running out to the sea. Is you run more? Don't you feel so free? Some folks wanna be just like you. Give them some feathers, bruh. Tell them what to do. Yeah, down the road you got nothing to say. They all crying out, help us find our way. You drink too much and then you end up in jail. Yelling through the bars, this ain't for sale. This ain't for sale. This ain't for sale. I said, hey, you run a boat. How you like that great big Cadillac? Hey, you run a boat. How you like that great big Cadillac? Hey, you run a boat. How you like that great big Cadillac? Hey, you run a boat. How you like that great big Cadillac? Right, yeah. I'll see you later, alligator. After a while, crocodile. I'll see you later, alligator. After a while, crocodile. Well, I saw my baby walking with another man today.
sorry, pretty daddy. You know all my love's for you. Won't you say that you forgive me? Tell me that you love me. Try a minute, pretty baby. Though you meant it to play. Wait a minute, pretty baby. I know you meant it to play. But you really have to be. This is what I got to say.
All right. See you later, alligator. At the wild crocodile. See you later, alligator. At the wild crocodile. Yeah.
See you later, girl. Now I'm a gator. See you later, at the wild crocodile. See you later, gator. At the wild crocodile. See you later, gator. At the wild crocodile.
Oh, yep. Well, it's gone to the right. What's up there? I said, boy, yeah, bang it on the bayou. Boy, yeah, too nude on the bayou. Boy, yeah, say food on the bayou. Boy, yeah, my travel. Boy, yeah, me her hats by the bayou. Boy, yeah, me her dresses by the bayou. Boy, yeah, her shoes by the bayou. Boy, yeah, she's naked in the bayou. All right. Boy, yeah, bell sur le bayou. Boy, yeah, plus qu'un eye sur le bayou. Boy, yeah, c'est tout sur le bayou. Boy, yeah, I'm a travel. Boy, yeah, her hats by the bayou. Boy, yeah, me her dresses by the bayou. Boy, yeah, me her shoes by the bayou. Boy, yeah, she's naked in the bayou. Don't do that.
So, in my estimation, in my opinion, and you know what opinions are like, right? Everyone's got one. In my opinion, you pretty much got the core essence of the CLR, right? In and of itself, right? That's really the Zen. That metadata is everywhere, you can extend the metadata, and everything is virtualized, right? That's the high order bit I want you to take away. What I'd like to do with the rest of today is talk about the world that is not the CLR. Right? I've shown you kind of a highlight of why the CLR is bitchin' and wonderful. And what I'd like to do now is come back around and say, well, but what about code that ain't in the CLR? And there are two primary scenarios I would like to talk about, and they're almost like exactly the same. One of the scenarios is, what do I do about all that COM crap laying around? And the other one is, what do I do about all that Java crap laying around? Right? We all have seen the path to goodness and righteousness is the CLR. But unfortunately, not everyone has been saved as we have. And so how will we, bring the great unwashed into our world? Well, first let's deal with the folks who do COM. Then we'll deal with the people who do Java and any other thing that isn't Microsoft, right? As by default, that means legacy, right? Those jokes used to be much funnier before I worked at Microsoft. Now they have this kind of ominous tone, don't they? I'm sorry. I'm only kidding. It's great that there are lots of vendors. It's a fantastic thing. Competition is goodness. Innovation is fantastic. There. Now do you feel better? Let's talk about reality. Someone came up to me during the break and said, Don, why does the C# compiler and the new C++ compiler emit files that have a .exe extension and a .dll extension? They're not DLLs, are they? Guess what? They are. The file format, thank you, of the CLR uses the PE and COF header as an envelope for the actual file format. So every executable, every DLL that I have built with the C# compiler or the VB.NET compiler is a valid Win32 PE executable. I can actually run tools like dump bin /exports on grass.dll. And notice it didn't barf. It also didn't print out anything interesting, but notice it said, oh yeah, that's a COF PE executable. Cool. By the way, as a historical aside, I hope you all know that the Visual C++ compiler from day one has actually been producing MZ files, right? MZ was the initials of Mark Zabowski, I believe is the way you say his last name, who worked on the DOS team who came up with the original .exe format. And if you ever take a program you wrote like with VC6, put it into a time machine, go back to 1985, run it on a DOS 3.1 machine, it will in fact run. And what does it do? It prints out a message saying, you need to upgrade to Windows NT, enter credit card number here, and then it goes out and gets the bits, or something like that. Right? It doesn't barf. Right? That's the observation. Similarly, these programs don't barf. But a Windows app is not an interesting DOS executable. The DOS part just says go upgrade to Windows. The Windows part of a .NET executable is also not that interesting. Specifically, we don't export diddly squat, and let's look at what we import. I'm going to run dump bin /imports on grass.dll. And notice that I import exactly one other DLL. MSCore EE.dll. What does MSCore EE stand for? It's easy. MS stands for Magnificent Software. Core stands for the Component Object Runtime, one of the original names of the CLR. EE stands for Execution Engine. This is the last COM DLL ever written by man. 1,000 years from now, when software archaeologists are tracing back the origins of component software, and they find the rust-encrusted hard disk of my laptop, they will find this is the last COM DLL that was ever written. Some developer sat down at a machine in Microsoft and said, I will write this COM DLL so you never have to again. And it is a classic, unmanaged, native Win32 COM x86 executable. It is OLE32. Right? For all intents and purposes, it's the OLE32 we need. And please notice that what happens is, not only is that the only DLL I need, I'm only relying on one function in that DLL. And that function is core DLL main. Guess what? The entry point from a Win32 perspective, the entry point in my DLL is a small native x86 stub that's produced by the compiler that simply calls into that function. So when you need to do a DLL, process attached to me, I just forward it down to the runtime. You want a DLL thread detach? I forward it down to the runtime. Similarly, if I do this same tool against app.exe, it too relies on MS Core EE, but instead of calling core DLL main, it calls core exe main. And core exe main goes off, initializes the runtime, finds the main method, and calls it. Make sense? So MS Core EE is an important DLL, and it's the last COM DLL ever written. There's one more DLL you need to be aware of. That's called MS Core lib.dll. That is the first managed DLL ever to be written. So if it turns out 1,000 years from now, people decide to change the Gregorian calendar and all the calendars that we're using to all be based on the shipping of .NET, so that February 13th, 2002 becomes 0, then the ADBC switch will be based on MS Core EE and MS Core lib. MS Core EE is the last of the old. MS Core lib is the first of the new. And every new component you write needs both of them. We have a old school reference to MS Core EE, and please notice that we have a new school dependency on MS Core lib. Y'all see that? I need both DLLs to live. Cool. Now, let's talk about COM. I'm going to write another component. What's in the news right now that's not death related? Oh, I know. Public interface iEnergy company. So we'll write an abstract interface. Get market cap. Bool. Goodbye. How about this? Even better. Is hiring. Pardon me? We can argue about precision later. Public class Enron iEnergy company. Public double get market cap. Return double dot min value. Public bool is hiring. Return false. I think they've got enough people right now. Okay? Let's build this. Well, that would be system.double. Woohoo! Is that a valid Win32 executable? Yeah. Not an interesting one, but it's valid. Is it a valid COM executable? Does it have a DLL get class object? No. Does it have a TLB? No. You with me? But we can use it anyway. So, what I'm going to do is give you a preview. I may lose my job at Microsoft for doing this, but I'm willing to risk it for you because you're all nice people. I'm going to give you the first public demonstration of Office.net. Let me crank it up for you. Don't be confused by the fact that it looks exactly like Office XP. It's .NET enabled, and I'll show you why. Let me bring up a classic COM development environment. VB6, right? This is VBA6. This is classic COM, vtable, iDispatch, love, right? The way we used to know it, right? Back when we were young and naive. So, let me go ahead and bring in a couple of DLLs. I'm going to bring in MS Core EE and MS Core lib. Remember, MS Core EE is a COM DLL. Most good COM DLLs have type libraries. Therefore, I can program against it. So let me write a little VB program that will turn this Office XP application into the exciting, all singing, all dancing Office.net. So, I need to give you a little bit of VB background. In VB, we build forms-based apps. VB user interface guidelines mandate that at least one button occupy 2/3 of the real estate. And away we go. Let me make the font bigger for those of you over 20. That should be good enough. Okay. What I'm going to do is dim CLR as mscoreee.core runtime host. So this is going to be an object reference, a COM, vPointer, and vTable that is exposed by the CLR that says, hey, I'm a COM object. So I can program against the CLR as a COM object. And because this is a COM program, I can't imagine having one without this. Right? Remember those? Right? Vertical thumbs, right? Remember all this fun stuff? I'm going to need one of these things, which I'll explain in a second. And then finally, dim foo as object. Cool. Let me show you the one line of Visual Basic every person should know. There it is. So let's get started. The first thing I'm going to do is say set CLR equals new mscoreee.core runtime host. This is going to call co-create instance, which will look in the registry, and in that registry key we will find mscoreee.dll registered. mscoreee has now been loaded, but it has not been initialized because there are any number of configuration parameters that I can provide. So I'm not going to provide any. I'm just going to go ahead and get it started. So we're cooking now. The CLR has been fully initialized. The garbage collector has been initialized. The finalizer thread is up and running, waiting for finalization to happen. All the stuff you know and love has happened. In fact, going back to core exe main, that thing that my exe winds up thunking down to, I've done 90% of it in these two lines of code. Now what I'd like to do is get a reference to the default class loader, right? The default place where code can run. So to do that, I'm going to say clr.getDefaultDomain. We have these things called app domains, which I'll explain in just a second. App domains are like processes. They are isolated execution environments. They have their own security configuration. They have their own path configuration for finding executables. They have their own, in essence, their own address space, right? But it's not a hard address space in the OS sense. But the important observation is object references cannot be shared across app domains. So, set AD equals temp. And now what I'm going to do is do the moral equivalent of VB's create object. Remember how create object worked in VB? Right? You'd give it the prog ID, and it would go out, find the class, load it up, and away we go. So what I'm going to do is say, set foo equals ad.create instance. This is the moral equivalent of create object. And I need to tell it what component. And so I'll say go to mscore lib, and make me a system.collections.stack object. So now there's a stack object that got created down in the runtime, and I can talk to it. So let me go ahead and say foo.push, hello, foo.push, 42, foo.push, true, foo.pop, foo.pop, foo.pop. And notice that the last, when we had the empty stack, what happened? It threw the exception in the CLR, which got mapped to an H result. Make sense? Now, question. Is the system.collections.stack object that is in memory, is it a COM object? Or a more fundamental question is, are CLR objects COM objects? The answer is a resounding no. The objects in memory that we are programming against are not constrained by the COM physical layout. We live in a virtualized layout system, so we make them as small and as fast as we humanly can. Now, what do we do when someone needs it as COM? So for example, when I called ad.createInstance, we reached into the CLR, made a new object, and needed to bring it out to the world of COM. What we did was we did something which every COM programmer is familiar with. We marshaled. We marshaled not across apartment boundaries, because the CLR could care less about apartments. Rather, we marshaled across the managed, unmanaged boundary. And we had an object reference down in the CLR that kind of expected the CLR characteristics of running. But to make it programmable up here, what we had to do was stop it from wiggling for a second, allocate a new COM object that was linked to that guy. We call that COM object a proxy. That COM object is a proxy or facade on top of the real CLR object. And we give you back, in this VB program, a pointer to the proxy. And when you invoke methods on the proxy, we actually flip modes of execution from unmanaged to managed mode. Execute the code, and then flip the mode of execution back. And we bring any parameters with us, including object references. So the stack object that I am programming against is not a COM object, but we can allocate a COM object that looks just like it when we need it. And we call that thing a COM callable wrapper, CCW, because it's callable from COM, and it's a wrapper. Why don't we call it proxy? It's a proxy. You know why we don't call it proxy? Because proxy sounds slow and bloated, whereas wrapper sounds thin and lightweight and fast. But guess what? It's a proxy. Okay? It will take at the very least, if all the gods are in alignment, 32 extra x86 machine instructions to hop over and come back. Realistically, it will take hundreds. And if I'm not savvy about how security works, it will take thousands. Okay? But it will work. And in the normal case, it'll take 100 or 200 instructions to make the jump. Primarily because we have to crawl the stack to do security work. Because we live in a secure execution environment, and the ability to call out of the runtime is a privileged operation that we have to make sure you and everyone calling you has. So one of the real performance hits is the stack crawl we take, actually going in the other direction. We don't take a security hit to call from outside in. Because, hey, if we're on the outside, we're already in, buffer overflow mode, right, where we can do anything we want to kill ourselves or shoot ourselves in the foot. Right? But when we flip in, that's when we enter the secure execution mode. Going into that mode is cheap. Coming out is expensive. Okay? Now, let's program against our code. Remember our little Enron component that we wrote? What I'd like to do is program against that in this strange land we call COM. Well, for me to program that thing in COM, I guess I could do it with iDispatch, so let me do this. I'm going to change this call to create instance from, and the DLL is in demos TechEd 2002 enron.dll. Okay, that's the DLL I built, and the type name is Enron. Okay? So my DLL just got loaded. And I should be able to say foo.get, forgot the method name, foo.get market cap, a really low number, right? Foo.is hiring, false, look good. But I had to use iDispatch. By the way, I didn't have to write anything to get the iDispatch because on the CLR side we have metadata. And that COM object, that CCW that we build, implements a lot of the standard COM infrastructure interfaces like iDispatch, iMarshal, iPersistStream, I provide class info, all that stuff, right? That we used to do it in the Clinton era, right? It implements all of the Clinton era interfaces in the Bush era, right? And it does it in terms of how the Bush era works. So all that stuff is going to work just fine, but I'd really like to have a type library. I'd like to have the metadata in a format I can use. So to get that, I need to run a metadata converter. And that metadata converter looks like this. I'm going to run a tool called tlbexp.exe. And what this guy does is he takes a DLL, a managed DLL, a new DLL, and he produces a TLB. Y'all with me? So now, what I can do is stop debugging for a second. Let me go to Tools and References. And what I'm going to do is go browse for that DLL. So that's in Demos, TechEd 2002, enron.tlb. Notice there's my Enron type. And now I can go up here to my code and dim foo as iEnergy company, right? And now when I run this sucker, I'll crank up the runtime just like before, and I'll go ahead and do the set foo. Now when I do a foo dot, I get the IntelliSense, and it's all strongly typed, and it's going to be faster, and all the stuff we know about why iDispatch was such a piece of crap. We don't have to suffer anymore. Make sense? Now, I can go the other way as well. I can take a COM TLB and run the opposite tool, which is called TLB IMP for import, and get a managed version of that metadata that just goes the other way. So we have the ability to convert the metadata formats in both directions. Okay? The one thing we haven't addressed yet, though, is what happens when I do this. What is that going to do? When I say new in VB6, what did that do? Triggered a call to co-create instance, right? God's function. Right, let's try that. Do 800400154. Reg DB under E under class not reg. Right? Should look familiar to most of you. What happened? Co-create instance has a special place that it looks for your component. Where is that? Hell. It looks in hell. And .NET components do not live in hell, but we can put them there. Or at least we can commit their souls to hell and let them stay wherever they happen to be. So what I'm going to do is run a second tool called regasm. Right? Regasm takes the name of the DLL, which is enron.dll. Oops, hold on. I ran it the wrong way. It should be regasm/codebase. That should actually be the default. And we'll probably get some warning, which we can safely ignore for right now. And so right now, what I've done is I've said, go out, infer a class ID. Right? So that type name, actually we can hash the type name and come up with a GUID that will be unique for it. Right? So we basically do a digest over the type name and the surrounding assembly name. And that's the class ID. And now, sorry, if I do a start Olay view, this will be really hard for everyone to see, so let me go ahead and run the magnify tool. So what I'm going to do is show you that in Olay view, the first component category is .NET category. And if I crank that guy open, you'll see eventually there's Enron. Okay? So I now have a registry footprint. This happened when I ran regasm. And now what I'll do is select that and notice that the inproc server 32 maps to what? MS Core EE. Remember, that was the last COM DLL ever made. So when you call co-create instance against my GUID, the registry will redirect you to load MS Core EE. And if I walk down all of the entries in this list, guess what? They all point to MS Core EE. So here's the question. Based on the class ID, how will the runtime know which code to load? Well, it turns out that there are some additional attributes which are written to the registry. The class name and the assembly name. The assembly is the component name. And the code base hint that says where the DLL actually resides, which is in that hard-coded path. Make sense? And so what happens is MS Core EE has a generic class factory that it gives out in DLL get class object. He simply caches the GUID when you call create instance, when someone calls create instance. We go look up in the registry, find this information, cache it, and then away we go. So now, if I go over to VB, notice it no longer fails. And when I do get market cap and foo is hiring, away we go. So I was able to make my .NET component a first-class citizen in the world of COM. Make sense? So if I've got down-level clients like VB6 clients or C++ clients that I, for some reason, don't want to recompile against the CLR, I can still take advantage of the new code. Going the other way is actually fairly doable as well. Let me get rid of magnify since it's driving me crazy here. Let's go ahead and write a new VB component. Ooh. How do I write a COM component? I know, there are some on my machine. I don't know how to write a new COM component anymore. So, what I'm going to do is run TLB IMP. Oh, in fact, I don't even need to run TLB IMP. Watch this. I'm going to write an application that starts up Excel that basically calls co-create instance. So had I run TLB import over the Excel type library, it would have generated a class called Excel document. It's actually an Excel application. Okay? And it would have marked this class as being com import. When a class is marked com import, this is a hint to the jitter that there ain't no code for this guy. That instead, this is a com type, and calls to new against this thing need to be just-in-time compiled to be calls to co-create instance using the GUID, which I list here. So I just need to put in the right GUID, so 000200812, 0000 dash 0000 dash C000 dash 123412341246. Remember that one? It was a big hit back in the 90s, right? During that whole grunge rock era, like Nirvana and, you know, the Excel GUID, they went hand in hand, right? Seattle's biggest exports. Anyway, so my humor is lost on you. Excel application, app equals new. Excel application. Okay? And let me do a console.read line. So I'll basically prompt for you to hit return. CSC, Excel app. And what I'm going to do is bring up perfmon, so you can see that Excel is probably not running right now. So if Excel were running, it would appear between Emacs and Explorer, but it's not. What I'm going to do is go ahead and run Excel client.exe. And notice that Excel exe gets launched when I do the new. And I've now got what's called a runtime callable wrapper, which is an in-memory facade on top of the com object. And when I call through it, you know, it takes this perf hit to call out to the other mode. Make sense? And I can run TLB imp to get all of the interfaces brought into this world. There are attributes for pretty much everything you could say in IDL. So is it a dual interface? Is it a DISP interface? What's the DISP ID? What's the GUID? All of these things you're used to putting in IDL, you can actually put into the metadata in CLR land, either by typing it in by hand, which was the way I did it, or if you run TLB imp, it'll do it for you. Make sense? So the bottom line is we have the ability to flip back and forth between the metadata formats. That's the important observation. Okay? And the loader on both sides, we have the ability to hook them. So I can do a load from here and it works over there. I do a load from there, it works over here. Okay? So that's the com interop story. You can write components, put them in com plus explorer. If we had more time, I'd show you how to do that, but I want to show you some web service and XML stuff. So I will leave that as an exercise for the reader. I am sure there are sessions on it here at TechEd. Please go see them. Just let it be known you can do that if you want to. What I'd like to do now is move away from the com interop stuff and tell you the exact same story, but against Java. Right? So why do we need to do com interop? Because there is code out there that is written in com that ain't going to be rewritten. How are we going to bring it over? Guess what? There's a lot of technologies that aren't the CLR that we would like to be able to talk to. For com, we have a special story because it's so intimately integrated into the platform. For everything else, there is XML. Right? If it is not com, if we're going to integrate that code, we're going to integrate it through XML-based interfaces. And what we're going to do is pass XML-based messages between components. And we will build metadata and type using W3C standards like XML schema and WSDL. Web Services Description Language. And if you look at what XML Schema and WSDL give you, they give you the moral equivalent of COM IDL. So pretty much anything you could express in COM IDL, you can express in WSDL and XML Schema. And just like before, we have metadata converters that flip back and forth. So let me show you how this metadata converter works. Let's start by doing some straight XML programming, and then we'll flip over to do some web service programming. And then I'll cut you guys loose for the break. Okay, so let me write an XML schema. XML schema is a full recommendation of the W3C. It was ratified almost a year ago as a full recommendation. Vendor support is pretty good now, and it's only getting better every month. Right? So all the vendors in this space know that XML schema is probably the most important standard on the planet. Because if we can't get that right, we suck. Right? And people won't use this XML stuff. So XML schema has a type system and a metadata format for describing those types. So what I'd like to do is write an XML schema document and then do some work with it. So what I'm going to do is write a document called wedding.xsd. XML schema documents are themselves XML. So there's an XML syntax for writing a schema. The namespace is www.w3.org/2001/XML schema. And I'm going to describe types in a namespace. And that namespace is just named by a URI, and I know where I can get a really good one. And I like them to be all uppercase. So we'll make it all uppercase. And I'm going to bind that to a prefix. Cool. Now, I'm going to define a new type. This is like defining a C structure. No methods, only representation. So complex type, name equals person. And we will say that a person consists of a sequence of child elements, the first of which will be an element called name, whose type will be the built-in type string. And because it's a built-in type, its namespace is XSD. I'll have a second field called age, which will be of type double. And now, I'm going to define a second type called a marriage. This will consist of an element whose name is husband, whose type is what? Person. In what namespace? Target. Okay? We'll also have a wife. Oh, wait. I do a lot of European tours, so I localize the talks. So no, for here, this is the way marriages look. Agreed? And now what I'm going to say is that it is legal to have an element in this namespace whose name is wedding, whose type is marriage. Cool. Now, I have a perfectly reasonable type definition in a metadata format that is not the CLR. Just like when I wrote COM components and I had a TLB. I had a perfectly reasonable metadata format, but it wasn't the right one for the CLR. What did I do with COM? I ran a tool called TLB imp. what do we do here? I run a tool called xsd.exe. So what I'm going to do is run the tool xsd.exe on wedding.xsd. And I need to give it the /c option. And it's going to write out a C# source file called wedding.cs. And if we look at this, it has taken the types from the XML schema and given me CLR compliant metadata. So I've got a type called marriage with a husband and a wife, both of type person. And notice that to retain the fidelity with XML schema, we keep around extra attributes just like we did with COM. So in COM, if I import a type library, we have all these attributes to keep things like the GUID and the disk IDs around. Similarly here, we have custom attributes to keep the namespace declarations around and the unqualified versus qualified around. All these details, right? And there's also a person type. Now what's really great about this is if I have an instance of this type, which I will write now, in a file called input.xml, husband, name, Don Box, name, age, I like it better this way. My wife's name is Barbara. She is 1 year older than me. And she's my wife. We understand the roles in our relationship. Don't let this XML fool you. Cool. And I just need the namespace declaration and we'll be golden. Whew. Great. Now, let's write a program against it. Because I took the schema type and was able to infer a CLR type, guess what? I can now program against the CLR type just like it was written in C# or in C++ or VB or whatever. Schema is just yet another programming language in the pantheon of .NET programming languages. And so I can write a simple program that looks like this. So what I'm going to do is declare a reference of type marriage and say, oops, and say nothing yet. The more important piece of magic that I need is I need to make an XML serializer. XML serializers are metadata-driven XML parsing engines. So SIR equals new XML serializer over marriage. So I give the XML serializer the metadata for the marriage type. It then generates code one time that has the I/O code to be able to do the reading and the writing of that type to XML. And so now to get this guy to work, all I have to do is say sir.deserialize console.in. I'll just read it from the console. And now I can do something with it. Console.writeLine, obj.husband.name, we'll put a little formatting on here. Okay? Then we do the same thing with wife. And away we go. So I'm going to compile client.cs, and I'm going to include wedding.cs. And now what I will do is run client feeding it input.xml. Make sense? So even though there was an XML-based representation and an XML-based type, the CLR is kind of like the federator of type systems. Right? It takes the type system of COM, the type system of XML, and brings it into life so you can program against it. Right? And so now my program is pretty easy. What I can do as well is use this to go the other way. So if false, what I'm going to do is do some processing on the data. So what do we know about marriage? Did you know that men who are married live longer than single men? So we'll do that. Of course, you know how physics works. What happens to women? Right? It's harder on the wife. So I've got the program. It reads the marriage in from the file, does some work on it, and now I'm going to write it back out. So sir.serialize console.out obj. Cool. Recompile the program, and now I will run it. And notice now that the generated XML looks a little bit different, right? I'm closer to my true age, at least emotionally, and my wife is older. Agreed? And of course, what's really great about this see where I'm going with this? You know, now we're really getting close to reality. Make sense? And within the program, within a single instance of client.exe, I am working with fast, strongly typed data structures. But across the boundaries, I'm passing the most interoperable format known to man. And in fact, those pipeline elements could have been written in Java. They could have been written in classic COM using MSXML. They could have been written in Perl or in Ruby or PHP or whatever, you know, esoteric fashion trend language you're into today. You could do it because pretty much everybody does XML now. Right? So this is goodness. And in fact, one interesting way to write the program would have been to write the program in XML. There are two XML technologies that allow you to program exclusively in terms of XML. One of them is shipping today, and you probably already know it, called XSLT. The more important one, which won't ship until late this year, is called XML Query. Right? An XML Query is a fully formed programming language that works exclusively in terms of XML. And, you know, my crystal ball says more and more people will be writing an XML query, you know, 3 years from now than you'll ever imagine. Right? It's the next big thing. Right? And the idea is it doesn't matter. Right? I can write part of my system in C#, part of my system in classic COM, part of it in XML query, part of it in XSLT, and yes, God forbid, part of it in some legacy platform. Okay? Now, all of this is running on one box. That is, I'm piping the input from the shell and then piping the output into the input to the next program. What if I want to do this across the network? Well, we need the ability to shove these XML data items from one node to another. And that's where SOAP and web services come in. So what SOAP and web services do is they give us a message wrapper to allow us to transmit the XML over things like HTTP. And in the form of WSDL, or Web Services Description Language, WSDL adds operational types so I know what it is I'm sending back and forth. So let me go ahead and write a web service. And this time what I'm going to do is I'm going to start in the world of C# and then infer the XML schema. So I'm going to go back the opposite way. So I'm going to write a new file. Public class number service. Public int init. Public int guess. So what I'm going to do is write a random number guessing program. And I'm going to implement it as a web service. But I'll start by just writing it as a type. So my random number program is going to have two operations. Init, which will generate a pseudo-random number and then encrypt it and give it back to you as a seed, is the way you start the game. Okay, so let's implement init. So I need a random number. The way I'll get one is it's pseudo. Don't believe me, this is not the right way to do it. I'll do a system.datetime.now.ticks modulo. We're going to do it between 1 and 100. And then plus 1. So number will be some number between 1 and 100. Agreed? I get the current high resolution tick count, and then modulo by 100 and bump it up. So instead of 0 to 99, it's 1 to 100. Now I am going to encrypt it. So you cannot easily guess it by looking at it. Do not worry. This is not the encryption algorithm we use at Microsoft for things like your passwords. Don't let the fact I work at Microsoft fool you. This is not a secure implementation, and I make no bones about it. But it's easily understandable. If you ask me later, I'll show you how to use MD5 or something like that. Okay. Now, in guess, I need to decrypt the number. So to do that, I will do what? Right? The symmetric encryption algorithm, right? High speed. This is way faster than all that public key infrastructure crap. Okay? And then I'm going to compare your numbers. So if value is greater than number, then I'm going to return positive 1, meaning you're too high. Else, if value is less than number, I'm going to return minus 1, indicating you're too low. Else, I'm going to return what? 0, which means you nailed it. Okay? Great. Now, what I'm going to do is save this file as numbers.soap. And at the top of the file, I'm going to add the directive web service language equals C# type class equals number service. So everyone see what I just did? I took my source file, gave it a different file extension. And now I've just said this little directive so the ASP.NET compiler can actually run on this thing. What I need to do now is create a new virtual directory over this guy. So to do that, I will go to Administrative Tools, IIS Admin. We create a new vroot. We'll call this one TechEd 2002, and I will point it to there. Cool. Great. Now, let's browse to it. Start http:// local host TechEd 2002 numbers.soap !WSDL. So what this is going to do is send a normal HTTP GET down to my server. The server needs to get initialized and all of that stuff, right? And I just rebooted my machine last night because I had to install some software. So it took, a few seconds for all of the plumbing to come up. And it generated this metadata. And I'm going to make the font somewhat bigger so everyone can see it. And notice that inside of here, somewhere, we have something called a port type. And the port type is like an interface definition that says, look, there are two operations, init and guess. Init has a request and a response type. Guess has a request and a response type, and these point to XML schema. And there is a tool called soapsuds.exe, which I will run for you in a second here. Soapsuds.exe minus URL colon that minus output assembly numbers.dll. So what this soapsuds.exe tool does is it's just like TLB imp. It looks at the or like xsd.exe. It looks at the foreign metadata format and infers CLR types. And I can now open up the metadata that just got generated. And notice that there is a type called number service with two methods, guess and init. And the signatures match what I had before. So now I can write my client pretty easily. Class app, static, void main, number service ns equals new, number service ns int seed equals ns.guess, init. So I'll make the first call to get the token, and then while true, we'll start by guessing at 50, and then we'll do a guess. So what I'm going to do in this little web service client program is connect to the web service, get the initial seed, and then iterate, trying to make a close guess. And I'll print out the progress as I go along. So let me go ahead and build this guy. CSC/R numbers.dll. So I'm going to reference the metadata that I inferred from the WSDL, and then give it client.cs, and let's try running it. Not bad, eh? Make sense? I was able to write the web service. The web service had methods that basically had underlying XML schema types. And that's what we sent back and forth. Cool. Now, you may notice that I saved the file. Let me go back to my server file. I saved the file with a .soap extension. There are two technologies that Microsoft ships in the .NET framework for doing web services. One of them is called .NET Remoting. The other is called ASMX for ASMX. .NET remoting is what I just used here because I saved the file with the .soap suffix. What I'm going to do is use ASMX and show you that it works exactly the same way. So I'm going to save this file as numbers.asmx. This is what you get when you use Visual Studio, by the way. And I do need to add an attribute, system.web.services.webMethod. And what I'm going to do is surf to the .asmx file. And notice that it looks different. It's because these are two independent implementations of web services. Okay? And in fact, there's a separate client configuration tool. So what I'll do is make dir /client2, copy client.cs to /client2. And now what I'm going to do is run the other tool, which is called wisdle.exe. This is just like SoapSuds. HTTP localhost TechEd 2002 numbers.asmx !wisdle. And it generates a source file. I have to make exactly one change. CSC client number service.cs. And when I run this guy, well, look how much faster it is, right? Although it's not always going to be faster. Oh, it's always faster. Look at that. That's great. There we go. Finally, I got one that took longer. Okay? Two implementations of the same thing. My God, this is a world record. Microsoft has never shipped two competing technologies that solve the same problem, have they? Which one do you use? Well, here's the deal. .NET remoting takes the attitude of, all I care about is the CLR type system, and I will make sure that pretty much anything you write in the CLR world, like a C# program, will be translatable to web services. And what it winds up producing is WSDL that other people may or may not be able to interoperate with. So for example, let me open up numbers. Oops, hang on. Let me open up the remoting server. And what I'm going to do is add one more method, public void haha. And I'm going to take a system.collections.hashtable. Like so. And I'm going to go generate the WSDL for it. And notice it has absolutely no problem doing that. And the message contains a hash table object, but there's no schema. What it does is it writes out some legal but useless goo in the WSDL that says, if you're the CLR on the other side, wink, wink, you know what this is. If not, I'm so sorry, thanks for playing, upgrade to .NET. Make sense? So if what you care about is interop and reach, which is the whole point, .NET remoting is not the right way to go. ASMX, in contrast, uses XML schema as the focus of the plumbing. And it does an infinitely better job dealing with arbitrary XML schema, and it is proscriptive. If I take this method and go over to numbers.asmx, and try and make it a public method, and recompile the ASMX, it's going to throw an exception. It's going to throw an exception because hash table is not a legal type. because there's no possible good representation for it in schema. Oops, hang on. Try that again. There we go. So notice that we couldn't reflect against the type because there's no meaningful XML schema rep for it. Bottom line, when in doubt, use ASMX. Right? .NET remoting is something you don't want to be investing tons of engineering around, because it is not the web service solution of choice. If what you care about is XML and web services and interop and reach and all of those goodnesses, then ASMX is the only game in town. Alrighty? Cool. So, we just spent almost 3 hours together. What did we talk about? We talked about why .NET happened. .NET happened because metadata wasn't extensible and binary compatibility blew chunks. And so I showed you before we took the break how the CLR addresses both of those things. The second half of the talk, we talked about why it's called the common language runtime, because it federates all of these other systems like C#, C++, COM, XML web services, and through XML web services, pretty much anything else out there in the industry. Because thank God, we know that XML web services, solve world hunger and are the solution to every problem. If you don't believe me, go ask management in your company. They will tell you this, right? So by doing XML web services, we don't have to solve the interop story for everyone else. And I'm being facetious, right? Web services are not the solution to every problem. But they're a very solid foundation and very, very important, and I suggest you spend time thinking about them. So it feels like a very reasonable time to stop the talk. I have a 5:30 talk in here after this, so I don't have anywhere to go but to sit here and answer questions. So this would be a good time to officially break, go get something to drink, and then I'll actually come back and just sit around and answer questions until 5:30. Great, thanks, bye-bye.